Assalamu alaikum, friends. Today we are going to learn the longitudinal waves, which is topic number 2, lecture number 2. If you haven't seen my previous lecture, that is about waves, the basic introduction about waves and the transverse waves, you can visit my channel and you can watch from the playlist. So, longitudinal waves. First of all, we will go through the definition and then one by one, step by step, I'll discuss each and every concept. These waves oscillate in the direction which is parallel to the direction in which the wave travels. Now, these waves oscillate. Oscillate basically means vibrate. These waves vibrate in the direction which is parallel to the direction in which the wave travels. Now, what does parallel word mean? Parallel word means that side by side. The opposite of parallel is perpendicular. We have already studied this. So parallel means side by side. So the direction of the wave, if the direction of the wave is towards right side, the waves will also oscillate towards the right side. And if the direction of the waves is towards the left side, the waves will oscillate towards the left side. So basically, I have always tried to explain my students in such a way that the concept gets clear. Look at the word longitudinal. Long itself means it is wide, long. So when we talk about longitudinal waves, it means they are going straight, somewhere straight, right? So straight is similar to the word parallel. In this way, longitudinal waves, wherever you hear this word, it must click to your mind that longitudinal waves means the waves are parallel and parallel to what? Parallel to the direction of propagation. Let us consider the example of longitudinal waves. Tie, tie the one end of a spring to a wall or anything and hold the other end of the spring to your hand. And when you move the spring a bit, to produce the vibrations, because waves are only can only be produced if the external force disturbance is created. So while creating the disturbance you have to move the spring a bit. You can clearly observe that the spring is moving towards the end of the wall, and there are few spaces, one where the spring is getting closer and the other where the spring is getting away. So the parts where the spring is getting closer are called compressions and the opposite ones are called rarefactions. So the distance between one compression to another compression is called wavelength, and the length between the normal line, neutral line to the above point of the spring is called the amplitude. These two terms were also discussed in the transverse wave too. As you have studied that compressions and rarefactions are formed in longitudinal waves, so these waves are also known as compressional or pressure waves because they produce compressions and rarefactions when traveling through a medium. Example of the sound wave, longitudinal waves is sound waves. You can hear a sound of a drum or a person talking to you.